Okay, so I'm back, and now we're gonna work with complex numbers. The first question is, given z1 equals to 2 plus 6i and z2 equals to 3 minus 4i, find the following. Part I, z1 plus z2. Now, before we begin, let's work out some complex numbers. So we're given that y is always equal to the imaginary number of square root of minus 1. So whenever we see a I, it just means square root of minus 1. When we see a y squared, that'll be the square root of minus 1 squared. What does this mean? That this will just cancel out and we get a minus 1. Square root and squares just cancel each other out. Now, so this means that to work out z1 plus z2, we just add the terms together. So the terms without the I add together, and the terms with I add together as well. So let's do it bit by bit. So 2 plus 6i plus 3 minus 4i. So this will be 2 plus 3, 5, 6 minus 4, 2, minus 2i. And that is the answer to part I. Now let's go to part 2. Or part II, as you can say. Now this part here, let me just bring it a bit upwards. Okay. Now let's work for part II. So this is 2z1, z2. This is the same as 2 times z1 times z2. Okay, so before we do the 2, let's deal with z1 and z2 together. So if we put 2 plus 6i times 3 minus 4i. So this is 2 times 2 plus 6i times 3 minus 4i. Now let's expand the brackets. When we expand the brackets, we've got to times with this value times that value, this value times that value, this value times that value, this value times that value. Okay, so now we get 2 times 3 is 6 plus 2 times minus 4 is minus 8i plus 6i times 3, which is 18, so it's 18i, and then 6 times minus 4i, 6i times minus 4i, which is minus 24i. Let me fix this a bit. It's 24i. Okay, so this part here becomes minus 8i. So, and this is 24i squared because we're times I by I as well. Okay, now this is going to be 2, 6 plus 10i is 24i squared. Okay, and this will be the same as 12 plus 20i minus 24 times 2, so it's 48i squared. Okay, now we get 48i squared, and I said before that I squared is minus 1, so at the end of the day this will become plus 48. So this will be 12 plus 20i plus 48. If you did not get, this means that minus 48 times y squared equals to minus 48 times minus 1. So the minus 1 will cancel that out and that will become 48. This is how we get that answer there. So the final answer will be 12 plus 48, so it will be 60 plus 20i. And that is the final answer to part II. Okay, so for part III is similar to the first one we did, but this time we're taking away Z2. So my advice is to put brackets around the equations so that we don't get confused here. So what does this mean? This means that any value inside that will have to be times by minus. So we get 2 plus 6i, and then minus 3, and then plus 4i. And at the end of the day, the answer will be 2 minus 3, so minus 1, plus 10i. And to tidy this up, I would personally put 10i minus 1, just to look better. And that is the answer to Z1 minus Z2. Okay, so now for part 4, IV, we gotta divide Z1 by Z2. So before we do this, we gotta know the rule for when we're dividing two complex numbers equations. So if we have Z1 over Z2, this will be equal to Z1 times the conjugate of Z2 divided by Z2 times the conjugate of Z2, also called modulus, because whatever is in Z2 will become positive. Anything will be positive. And we gotta times it together. So are we gonna do this? First, we write down the equation as it is. So 2 plus 6i divided by 3 minus 4i. Now we did this, and now we times this equation by the positive value of the denominator, which is 3 plus, it's always positive, 4i, and we do the same at the top, so 3 plus 4i. So at the top we get 2 times 3, 6, 2 times 4i plus 8i, 6i times 3 plus 18i, and then we do 6i times 4i, which is plus 24i. Now this is the top bit, bottom base, 3 times 3, 9. 3 times 4i is 12i. Minus 4i times 3 is minus 12i, so this 2 will cancel out, and then minus 4 times plus 4 is minus 16i squared, and that is y squared as well. Forgot about that. Try not to forget it though, because it's very important. Okay, so at the end of the day, this will become a minus 24. This will become a minus 24, and this will become a plus 16. So let's do the calculation. At the top we get minus 24 plus 6, that will be minus 18. And that will be 8i plus 18i, which is 26i. And the bottom is simply 9 plus 16, since these two values cancel each other out, and we get 25. And this is the final answer to the question IV. Now, this question is based on the graph theory, and the question is the following. The diagram shows the connection between 6 locations and cabling costs in thousands of pounds for connecting them. So we have 6 locations, A, B, C, D, E, and F, and this number here is 1,000 of pounds for the connection. Okay, so use Kruskal's algorithm to find the minimum cabling cost required to connect all the locations. Yeah, and it tells us to find a minimal spanning tree. Draw a resulting tree and give the total cost incurred. Now to do this, we gotta find the shortest routes first. So we gotta create a table that'll show the routes and how much they'll cost. But in this time, we're just gonna talk about how big they are. So this will be the smallest route. So this comes first. A, F comes first with a 2. So we tick that out. Let's tick it over. And then the next shortest route is E to F, which is 3. So we take that out, and then we have A to E, which is 4. And we take that one out. Then the next one will be 5, so F to B or B to F. You can put anything. I'm going to put B to F. B to F, which is 5. Let's draw a line from here downwards. Okay, the next one will be B to C, which is 6. So B to C, 6. Cross that out. The next one is A to B, which is 8. A to B, 8. Cross that out. Then C to D is 9. C to D is 9. Cross that. The next one is B to D, which is 10. Cross that out, and then the last one is 12, and it's E to D is 12. Okay, now the way this works is that we gotta find values that are small and that they do not repeat, because it's a tree. A tree does not make the circles. A tree starts from one end, goes to the other end, but never returns back. never returns back. So this is what we're trying to get. So A and F is the first one and the smallest, so we accept it. We put a tick or an A. E to F. Okay, so let's start drawing our tree. I'm gonna have A to F. So let's put F here. So we have A to F, and now we have E and F. As you can see, E and F goes there, so let's put E there. Yes, it does not repeat, so we keep E to F. And now we have A and E, so it will be this part here, but we don't want that. So we reject. Now B to F, so F is here and B will be there, so we can accept this. So it does not create a search or a path. It's always the same. It just expands, it never goes back. And now B to C. C is there, so we can actually do it. We have a C there. We accept this. A to B, we don't accept it. C to D, yes. We can accept C to D because D is not connected to anything so far. And now we have B to D. No, because B already has connections. We don't accept it, and then E to D we don't accept it. So we have our minimal spanning tree that has 5 lines, and the lines are usually the number of points you get minus 1. So we have 6 points minus 1, we get 5. And this is our minimal spanning tree. Now the question is, give the total cost incurred. So we gotta put the values that we got there. So this will be a 2, this will be a 3, this will be a 5, B to C is a 6, and C to D is a 9. So the total cost will be the sum of these values. So total will be 3 plus 2 plus 5 plus 6 plus 9, and this will come up to 25. So this is the sum of the values there, but we're told that the cost is in the thousands of pounds, so 25,000 of pounds. So 25,000 pounds will be the total cost. Total cost. And that's it. Now for part I, we are told to write down the adjacency matrix for the graph shown above. This graph here. Okay, so the first thing we gotta do is to actually write down the values that we get. So it's A, B, C, D, E, and F. So it's a 6 by 6 adjacency matrix. Now you do the matrix bracket, and then we put A at the top, then B, C, C, D, E, and F at the end. Okay, now do bracket again. Okay, now the trick here is to put a 1 when there's a connection. So between A and B there's a connection, so we put a 1. So A and B, we put a 1 there, and A and B, we put another 1 there. Now there's never a connection between 2 points unless we have a loop. If we had something that went like this, then we'll have a connection between it, but we don't. So we put a 0 there. And that being said, then this will also be a 0 because you don't have a connection between B and B. Now, do we have a connection between A and C? No, the graph does not have any connection, so we put a 0 and a 0 there as well. And this will keep on going. So, do we have a connection between A and D? Not really, so we put a 0 as well. And there will be another 0 there. But now, do we have a connection between A and E? Yes, it's there, so we put a 1. Connection between A and F? Yes, so we put another 1. And this pattern here will repeat on this side as well, so it's always symmetrical in the diagonal line. Now let's do B. Do you have a connection between B and C? Yes. Do you have a connection between C and C? No. So just fill that out. Now let's go back to B. Between B and D, yes, we have a connection, so we put 1, 1. A connection between B and E? No, so we put a 0. And a 0 there as well. Between B and F, yes, there is a connection, so we put a 1 and a 1. There as well. Now, let's think about this for a second. You can keep on going, but can you find easier ways to do it? So, what about starting from the bottom now? So, instead of keep on repeating yourself from the top, you can just go from the bottom. So, from F to C, do you have a connection? No, so we put a 0. And then go to C and we put a 0 there. Now let's continue. Now let's continue with C. So C and D connections, yes. So 1. Is there a connection between D and D? No, so we put a 0. You'll see there will be a line of zeros going down like that. It's normally like that all the time. So you have a C and E connection. No. So we've done C. Yes, we've done C. Okay, now let's do D. Is there a connection between D and E? D and E. Yes, there is a connection between D and E. And 1 and 1. Is there a connection between D and F? No, so we've got a 0. And we've got a 0 there as well. Okay, we're almost finished. Is there a connection between E and E? Nope. Is there a connection between E and F? Yes. Is there a connection between F and F? No. And this is our adjacency matrix. Remember, if you have a connection, it's a 1. If you don't have a connection, it's a 0. And that's all it is. Thank you for watching. See you guys in the next video.